Greetings captains and welcome to this VFR lesson in the Flight Sim School video tutorial series. My name is Thomas Rasmussen and to help me I have flight instructor Cameron AKA Voidhawk9 from the explain.org forums. Whatever the wind is doing, the circuit pattern itself remains essentially the same. We may need to adjust our flight to compensate for wind effects however. Here we'll look at wind blowing directly down the runway towards us, and later in this lesson we'll consider the effect of wind from the side. We'll not consider wind from behind us, as in that case we should be landing and taking off in the other direction. For interest, you may wish to compare approaches and landing distances of 20 knot headwind versus 20 knot tailwind. Try landing on a short runway with a tailwind, but never in real life. Let's set up the same situation as in the last lesson, taking off from runway 29 at Christchurch International Airport, November Zulu Charlie Hotel in our trusty Cessna 172. But let's first set up a 20 knot wind blowing down the runway towards us in the weather menu. Go into Flight Configuration, Customize Weather, and add a wind layer. Move it all the way down. Set wind speed to 20 knots and the direction to 290 degrees. We can check that the wind direction has been set up correctly ahead of us and not behind us by looking at the windsock in our end of the runway. Here, correctly showing wind blowing down the runway towards us. Let's consider the differences on each leg of the standard circuit. Takeoff and upwind leg. Having 20 knots of wind blowing onto us from ahead is equal to 20 knots airspeed, so standing still on the runway with the brakes applied, you are already moving through the air at 20 knots. Therefore, your takeoff will be shorter, your airspeeds are still the same, but your ground speed is less. Your angle of climb will be steeper, but rate of climb remains the same. After turning left onto crosswind, the wind is now from your right. If you make no change to your circuit, you will be blown to the left. To counter this, make your heading 10 degrees or so to the right, thus towards the wind. The wind is now behind us, so no worries about drifting right or left. You will notice, however, that you fly the downwind leg faster with the help of the tailwind. As on crosswind, the wind will blow you sideways. Again, turn towards the wind enough to keep a straight path to your aiming point. Hopefully, you've corrected for wind drift on base and have turned final in the usual location. Now with the 20 knot headwind, it is going to take much longer than usual to reach the runway. You could almost make yourself a coffee before making it to the runway. If you use the same throttle setting as usual, your descent will be steeper but at the same rate and you will undershoot the runway. To counter this, raise the nose and increase the power a bit, just as if you were dropping low on a normal approach. Fly the normal 3-degree profile. Landing is like normal and normal speeds, but because of the wind your ground speed is lower, so you'll use less runway to stop. If you were to turn up the wind speed to equal your normal touchdown speed, your landing roll would be 0. Now let's move on to the crosswind circuits. A crosswind circuit is any circuit where the substantial part of the wind is from the side rather than just ahead, resulting in the need for techniques to compensate. They frequently come with associated turbulence. Set the wind at 15 knots from your right. Angle should be between 60 and 90 degrees from runway heading. Go into flight configuration, customize weather, and let's edit the wind layer that we already made earlier. And set wind speed to 15 knots. And since we're still at runway 29 at Christchurch International, the wind direction should be about 350 degrees. Again, check the windsock that you got the wind direction right. Now, crosswind technique starts already on the ground while taxiing and before takeoff. Wind blowing onto the aircraft from the side tend to try to lift up the wing on the windward side, especially on high-wing aircraft like the Cessna 172. We can use the controls to minimize this problem. If the wind is striking your aircraft from somewhere ahead, turn ailerons fully towards the wind and pull back on the controls to raise the elevator. Have a look at the controls in this position and note where the wind is blowing from. The wind striking the aileron on the windward side will try to push the aileron and therefore the wing down, countering the lifting tendency. If the wind is striking your aircraft from somewhere behind, turn ailerons to follow the wind after it has passed over you. Set the elevator in a neutral position. Why not push forward on the elevator? Doing so would cause the wind to push the tail down, which is good, but the prop wash from the propeller, if it overcomes the wind, which is more likely with higher throttle, it will try to lift the tail up. A neutral position should be safe either way. Again, note the position of the controls and the direction the wind is striking them. Again, the windward wing will be pushed down. Again, consider the circuit with crosswind from the right or from the left. In both cases, you'll have to make heading corrections at upwind, downwind and final to compensate for the wind effect on your aircraft. We're at the runway ready to take off, ailerons turned all the way towards the wind to the right. We'll slowly increase to full throttle. Gradually return the ailerons towards neutral to be almost level when you rotate. At rotate speed, positively rotate to get the aircraft airborne. If you rotate too gradually in a strong crosswind, the aircraft tires may skid sideways as their traction reduces when the wing starts carrying more of the load. Allow the aircraft to yaw into the wind when it lifts off. Climb profile is the same as for normal circuit. Visualize a path using reference points in a straight line in line with the runway. You want to fly over this straight line, but the wind will try to blow you to the side. Adjust the aircraft heading to maintain the straight path all the way upwind. On the crosswind, the wind should be largely in line with your flight path, so only slight, if any, compensation for wind drift will be required. Your ground speed will be different, however. If the wind is from behind you, as in this example, you'll get to desired downwind spacing very quickly. Don't fly too far away. The only difference in the downwind will be that you need a drift heading to avoid being blown further away from the runway. While it doesn't really matter much where you reach circuit height when climbing, you do need to hit your target 500 feet above ground level turning final. To achieve this, adjust your rate of descent in the conventional manner. In this example, the wind is from ahead on base leg, so it'll take longer to get to the turn onto final approach. Reduce your rate of descent to avoid being below 500 feet prior to the final's turn. The more difficult case is probably where you have a strong wind from behind you on base, as your time to descent to 500 feet can be very short. Final approach is flown pretty much in the usual way until the flare, with the exception that you'll need to adjust your heading to remain on the center line. This can feel very strange, especially as you get lower and close to the runway while the nose is pointing off towards the side of the runway. We don't want to land going sideways, however. In most cases your plane can probably handle it, but the stresses on the undercarriage and wear on the tires will not be forgiving in the long term, while the stresses on your passengers may make things unpleasant in the short term. The flare to land in a crosswind is one of the trickiest techniques to get just right, but very rewarding when you do, because you know how difficult it was to get just right. For a normal landing, we're only really concerned about using the elevator to flare to the correct attitude. In a crosswind landing, we are using all three axes in different directions to achieve the desired smooth arrival. At the flare, we will transition not only to a nose-up position, but replace our drift heading with a wing-down position instead. Raise the nose as you usually would, but at the same time use the rudder to yaw the aircraft nose back so that it is pointing straight down the runway. Prevent the aircraft drifting sideways by rolling the aircraft towards the wind. In this example, the wind is from the right, so roll right so that the right wing is down. If you've managed to get everything right so far, don't expect to first time, then you'll touch down on one main wheel first. This is perfectly normal for a crosswind landing. Keep the aileron into the wind. As you slow down, increase the aileron towards the wind until it is fully deflected as we want it for taxiing. You've arrived. I told you it was tricky, didn't I? In the next lesson we'll talk about short field circuits. I hope you enjoyed the tutorial and found it useful. If so, please remember to share, like and subscribe. From Cameron and I, thank you so much for watching and see you very soon.